Okay guys, part 2 of the previous video with the basics. So relative compression, no, completely honest, I used to think was stupid, waste of time. I said, my ears can do a relative compression. You can hear in the cadence of an engine when it's cranking, you've got a mechanical issue of like low compression or something on a cylinder. You can hear it skip that cylinder and you know that you've got a mechanical issue. So I always thought, waste of time. Yeah, I get the whole diesel relative compression, because if you pull the glow plugs out and you're trying to do a manual compression test on a diesel, that they're a one-time use, you're not supposed to reinstall the glow plug. So I got the use there, but you know, I've been mainly a gasoline guy for most of my career. Been working on diesels now for a couple of years. But I was very wrong. I've actually had several cars now. I had one where wasn't even misfiring, ran fine. When you crank it, I could kind of hear it. It just sounded a little funny. It was a Ford Escape, a little 4-cylinder. Their issue is I'm volunteering at a church garage, and the issue was the car wouldn't idle, it would hunt for idle. And I mean, these guys, they put on lots of stuff, you know, the idle air control valve, the throttle body, tried to do, I don't even remember what all they replaced, trying to do relearns and trying to fix this idle issue. And I had seen them working on it here and there, and when I finally thought, you know, let me try to get to the bottom of this thing, I was cranking on it. It's like, this sounds funny. So I did a relative compression, and right off the bat, you could see that there was 2 cylinders that were low compared to the other 2. And what it ended up being, when I did an in-cylinder pressure test on it, you could see that the head gasket was blown and we're leaking compression. 2 and 3, the 2 center cylinders, were leaking compression back and forth. It wasn't causing a misfire. Car ran fine off idle. You wouldn't have noticed. It wasn't setting codes. There wasn't anything pointing to anything. But the relative compression, I mean, I hooked up to the battery and instantly saw that there was something wrong, did some further diagnosis, and we narrowed it down to a head gasket, and that was the issue. I had another one that was also not misfiring except under a load. It was hard to find. I knew it was cylinder 4 because it was misfiring under a load on 4 a little bit. It was hard to get it to do it, but it would do it. And there was a bolt-in for it, for cracked piston ring landings. If you had an issue like that, and Bolton said to, you know, bore scope and go look for some scoring on the cylinder wall or low compression or whatever. So again, it didn't have low compression, didn't always misfire, did a relative compression, and you could see that it was on cylinder 4, which I knew. But then once I pulled the spark plug, there was definite scoring on the cylinder wall, and I knew that, you know, at that point, basically needs an engine because cylinder wall's toast. So this is a very valid test. You can catch stuff that you may not be able to hear. It may not misfire, and it's a 5-minute test if that. It's super easy. So let's jump right in. I've got it all kind of set up, and then we'll look at the software. I'm going to get you turned around here. All right, so right here we got our green lead. Just runs right up. Let me try to get this on camera. It's kind of hard to do, so I'm just literally positive, negative on the battery. That's one way of doing a relative compression, is just looking at the battery voltage, and I'll show you that here in just a second, what to do on the software. Right here, trying to get it on screen again, I've got my amp clamp on the starter cable. So we're also going to do a relative compression using our amp clamp. And then, as you can see, I've got 3 channels hooked up. I've also got a cylinder sync, and I'll discuss the importance of that. But I'm just using my pickup that hooks right up to, just clamps onto your spark plug wire. And it's got a ground right there at the very front of the cylinder head. So that's going to give me an ignition trace to give me a cylinder sync. And the importance of that is when you do a relative compression, you'll have just a bunch of peaks. I'll show you this. And you don't know what cylinder is what. So if you do find an issue, you still don't know what cylinder it is. So that's where you want to put some sort of cylinder sync. And there's different ones. You know, of course, you can do like that one that I got hooked up. You got your ignition lead. You can do an ignition coil, the control side of it, and see when it's triggering the coil. You can look at the trigger on an injector, but you just got to keep in mind where, you know, in the rotation of the crankshaft, where we're injecting versus where we're trying to ignite that spark, you might be a little bit off, and so you just got to know, you know, what's what. So the easiest is really the ignition, because that really fires, especially during crank, real close to top dead center, and so you know that what cylinder that is. Of course, if you're doing in-cylinder pressures and stuff, that'll be a for sure cylinder sync as well. We can cover a lot of that in other videos. There's a lot of diagnostics you can do with your in-cylinder pressure. And of course, your pressure pulse sensors, both in your intake manifold or your exhaust. Again, a lot of non-intrusive tests, and there's some good content out there, but I'd be willing to put some videos together as well. Anyhow, so we're set up here. We'll go over to the computer. Okay, and I've kind of got my channels already set up, so, but I left them not fully set up to show you. So channel A is our voltage scale. We're currently reading 12 volts. Channel B, our red lead, is going to be the amp clamp, and then C is my cylinder sync. It's going to be my ignition pickup. And we'll go through this all. So with channel A, let me make the scope run and see, should see the difference. So we were talking on the previous video about AC coupling. So you can see right now, channel A is at 12 volts, or 12.6, or whatever it is it's reading. I could pull that up, but we're not worried about that right now. So AC couple, and it dropped my signal now. My 12.6 volts, or whatever my battery is now at the 0 line. Now, what that allows me to do is I can change to, so let's see, plus or minus 2 volts. And so this is still our battery voltage, but we're now at a zoomed in level. And so when we're cranking, you'll see it, and I'll show you. We'll be able to get those peaks and valleys and be able to get a good waveform and see our relative compression. Okay, and then channel B is our amp clamp. It's already identified it because it's a BNC plus. I've got it on a 500 amp scale just to make sure we capture most everything. And we'll go over that. And then channel C, again, it identified it as my ignition lead. I'm just doing 5 to 50 kilovolts. That'll be enough to capture on screen our spark event and give us a good cylinder sync. Then we talked about triggers, and what I'm going to do is I am going to use a single trigger. The nice thing about it, well, I don't know where my trigger is. Let's see. It's on channel A. I'm going to do a falling edge. You know, it's way up here. Okay, falling edge. So when I turn the key on, my voltage is going to drop a little bit, so I'll try to put it low. So I put it towards the front of the time scale. So what's going to happen is when I start cranking, I'm going to load the battery. So my battery voltage is going to drop. Once it crosses the threshold of my trigger, it's going to allow one screen of capture. So we're going to get all of our captures we're looking for going across the screen. Once it hits the end of the time base, it'll stop the capture for me. The reason that's nice is if you can't get to your computer fast enough, you know, this will capture a few screens of information. Depending, the longer your screen capture is, so 500 milliseconds up to 5 seconds, you know, whatever you're capturing. So if each one of these was 5 seconds, that'd be like 50 seconds of information. It's only probably going to capture you one screen. If you don't stop it and it moves on to the next screen, all that information's lost. So having this trigger on here is going to stop at the end, and so I'll have my capture, and I don't have to try to rush out of the car and go stop the scope and all that kind of stuff. So that's a real handy use for that. Okay, and now we're ready. I'm going to do a clear flood mode, which will allow cranking, and we're going to have the ignition events, so it'll capture that, but I'm not going to start the engine because I want it to continue cranking to give us a good long pattern that we can analyze. All right, so here we go. We're ready to do our cranking. All right, now I'm stepping out of the car, but you can see that it stopped my capture. So I've got all the time in the world to walk back and come see what we captured. And let me clean this up a little bit and start over because I'm not on the right. Oh, I'll do it again with you guys. I'll clean this up. I'm going to start it again. I'm not on the right cable for my starter, so for the amp clamp, so we didn't get a signal there, so I'm going to reset real fast. Okay, we're set up. We're going to do one more relative compression or one more cranking session, get another capture. Sorry about that. All right, so here we go, another capture. All right, so again, I get to walk over here and it's already stopped the capture for me. So now we have a relative compression, all of our traces. Right now, I'm gonna turn channel C off, kind of clean up our screen a little bit and go over the differences in the voltage capture versus the amperage capture. Also, to make our peaks a little bit larger, I'll change my scale. See if that 100 amp is just a lot more detail there. And also, what I didn't show you is digital signal processing. This will clean up. See, we got a lot of noise in our voltage here. So I'll just turn on the low pass filter, which really cleans up and gives us a much better view now. I can also make those bigger by changing the scale. Go down to 500 millivolts. I'm just making it a lot bigger. Makes it a little bit easier to see. And I'll separate these two. So, okay, let me pull a ruler down here. And that's what's nice about the Picoscope too, is you got your rulers. It'll measure exactly, this point right here is going to be 99.85 millivolts, and that's above your zero line. I'm just showing you that. It shows you your voltage. Really, though, sorry. Let's slow down here a little bit. So this is our voltage capture, right? So this is the one on the battery. You can do one or the other. I'm just comparing both an amperage and a voltage capture for a relative compression. When you use your battery, you are looking at the lower peaks. As if you think about, as your cylinder is coming up on compression, it's loading the starter. The starter's drawing more voltage, really more amperage, which causes the voltage of the battery to drop lower. And so your starter is working harder at the lower peaks to overcome that compression of each cylinder. So you are looking at the bottom of the waveform for your voltage capture as your relative compression. And you can see there's a little bit of a difference. You could almost think this cylinder right here might be a little bit low on compression. And you could see count over 8. 1, 2, 3, 4, 5, 6, 7, 8, and it repeats the pattern. So there's a possibility that there's a cylinder that's not contributing or doesn't have as much compression as the other cylinders. And then vice versa on your amperage, your amp clamp, your amp relative compression, we are looking at the upper peaks. Because again, when you are trying to overcome the compression of each cylinder, it takes more amperage as it fights that compression. And so your compression peak is going to be up at the top on the amp clamp. That's the only difference. Basically the only difference. And so one doesn't necessarily have more detail than the other that I have noticed. So you can do your relative compression either with an amp clamp or literally just hooking up to the positive and negative on the battery, which is typically how I do it because it's super easy and fast. So that's basically in a nutshell, that's your relative compression. We can see you have now so these are your y-axis rulers that will measure amperage. If I draw down the red one, your red ruler. Over here we got a blue ruler. It's going to tell, the voltage readings of what we're reading. And then you have your x-axis time ruler. And it's going to measure the time if you need. What also is very nice is you can line up. So let's look at this low cylinder, what looks like a low cylinder. It's the low peak here, the high peak here. They line up perfectly on the time scale. So let's look at this one right here. And it is, you can see it again here, relatively lower in amperage to overcome the compression on this cylinder than it is, say, like the two adjacent cylinders. Is that enough? This might be enough for me to do like a full compression test. I'm not going to. This is my personal vehicle and it doesn't misfire. It's like, oh, okay. I might be finding issues with my own truck, but so again, you can count 8. 1, 2, 3, 4. There's a low one. 1, 2, 3, 4. There's a low one. 1, 2, 3, 4. There's a low one. 1, 2, 3, 4. Then it's a little bit higher, so it's kind of hard to tell. I don't have any misfires. There's no issues with this truck. So, anyways, that's kind of the difference in the two, and you can see they're reading exact same information. So, let's move this up a little bit, or maybe I'll change my scales so I can drop it a little bit. I'll go to 1 volt, and we'll go to 200 amps. Make these traces a little bit smaller. Let me get rid of all the rulers, clean up our screen a little bit. Draw up both traces. And then we're going to turn channel C back on. All right, so we are on cylinder 1. So this is each time cylinder 1 fired the spark plug. So again, if I take my ruler, let's get over here into where the pattern is better. So you can see this low peak here. This is cylinder 1. This high peak here, this is cylinder 1. The firing order is 18726543. So if I suspected this one being a low cylinder, that would be cylinder 3. We know that because if it goes, follow the pattern. So 1, 2, 3, 4, 5, 6, 7, 8. That'd be a low cylinder again right here. Okay, if we go here, this is cylinder 1, 872654, cylinder 3. So this is kind of your importance of doing your cylinder sync, because now I can tell you if I were to do a compression test, cylinder 3 is my cylinder in question. So for further diagnosis, you're going to focus in on that cylinder 3. And I know I repeat myself, but again, you can do just your voltage, just your amperage. Doesn't matter if you don't have an amp clamp, do the voltage one, or vice versa. You just want one of these, relative compression, and a cylinder sync if you find an issue. If you don't even know you have an issue, just hook up to your battery and do your quick relative compression. If you draw your ruler across and just say all these peaks are relatively the same, they're all at the same line right here, you're like, okay, my test shows me that there is not a mechanical issue with this engine as far as compression goes. Then you can stop right there. Or say you got one that is just really off and it's like, man, that one's not, and it's obvious and it's a repeating pattern every 8th cylinder. You can see I definitely have an issue. You then have your cylinder sync. I know this is cylinder 1. I can then identify the cylinder in question. And that is your whole relative compression in a nutshell. And you can build from there by going into manual gauge compression tests, or you can do in-cylinder compression tests, and there's a lot more detail with your in-cylinder. So again, a manual gauge versus the Picoscope with a pressure transducer is going to be night and day different in how much information you can gather from each one. So again, I would be headed in probably with a pressure transducer to cylinder 3. I'd probably do a couple cylinders to compare, and then you can get into, if I suspected a lifter issue, which is common for GM engines, I could do like a pressure pulse sensor in the intake, or I could do a pressure, and also the exhaust. Really, I could do both of them and compare and see if relatively I'm moving less air in that cylinder because maybe I have a weaker intake pulse on that cylinder versus the other ones. And I could be like, okay, it looks like it's on the intake side, could be the intake lifter, or it could be on the exhaust side, and you should probably be able to pull that up or see it with a pressure pulse sensor. That's further diagnostics that we can make further videos on. I'd rather have a vehicle that is actually broken to do those kind of videos where we could kind of see what it would look like. So, but in a nutshell, that's your relative compression. That's what you're looking for. And here's your trigger right here, remember? So when I first started cranking, just to get that engine running, it really loads up the starter and the battery. And so my voltage dropped across this threshold, and as soon as it did that, it allowed it to continue recording one screen of information, and it just shuts it off. So that's how that single trigger works. There's different kinds of triggers, and we'll do different ones in different videos and cover all that. So that's it. Again, if I went over anything too fast, I know I kind of just wing these videos, so I can either go too fast or repeat myself 100 times. If I went over anything too fast, didn't cover something in enough detail, you want more information, leave some comments, let me know. If you want to see other kind of tests, pressure pulse in the intake or exhaust, or further do like a, my mind goes blank, the pressure transducer in cylinder testing, and look at that kind of stuff. And we can do all those kind of videos and really kind of dive in deep and cover some of this stuff. And again, there is a lot of good content out there for that, so I'd be more than happy to make those videos as well. Comment, like my videos, I'd appreciate it. Share them, subscribe if you like my stuff, and let me know what else to cover, and we'll get into it. I'd like to do a lot of can diagnostics. That's really helpful on probably any vehicle, but GMs, we run into that a lot with harnesses that are shorting out or whatever kind of problems we're running into. So I'll do some videos on CAN bus. Picoscope is super powerful for that. So, all right, we'll see you guys next time.